hooking you up to the brain stimulator.
That was, we're going to be hooking you up to the brain stimulator.
You might feel a little tingle in the back of your head right here.
Before we allow you viewers to watch the brain inside of this head subjected to 25 minutes of 1 to 2 milliamps of electric current in a laboratory, a solid 150 miles from this TV station's coverage area in the name of journalism, allegedly the advancement of this reporter's career, and yes, science, let us first allow the man who runs this lab to explain why.
As we age, there are certain brain networks that are uncoupled or disconnected.
The synchronization of brain waves made up of millions of neurons firing together in rhythm create these brain networks. Researchers like Boston University Assistant Professor of Psychological and Brain Sciences, Rob Reinhardt, believe this coupling of waves indicates communication between one part of our brain and another. For every human, the waves in the brain network responsible for executive function,
our ability to maintain our attention, hold things in mind, retrieve items from our long-term memory,
start to decouple in our late 20s.
I walked into another room and said, gee, why did I come in here?
Colin Riley describes what many of us recognize as a senior moment.
I can remember where I heard that, but I can't recall who the band is.
In a study published in the journal Nature Neuroscience, Reinhardt found by using a state-of-the-art electrode cap to apply 25 minutes of non-invasive electrostimulation, he could resync those decoupled or decoupling brain networks to boost short-term memory in those like Colin in their 60s and 70s to levels consistent with the working memory of a 20-year-old for nearly an hour after treatment.
We can essentially shave about 50 years off your life in terms of your working memory performance.
Which brings us back to the experiment Reinhardt used to reach his conclusion.
Let's know if we're ever poking too hard here.
An electrode cap makes contact with one's scalp with the aid of gel and some slight abrasion to remove dead skin cells.
Oh, I feel some tingling.
Electric current, equal to around 8 times less than that drawn from a 9-volt battery, then runs from the stimulator through the cap onto one's scalp and into their brain.
We present you with a high complex object, high fidelity, high quality image.
And after a brief delay of some seconds, a second image, either identical to the first or only slightly modified, flashes across the screen. The subject must then press a button to indicate whether the image changed.
I saw some things I didn't see before.
The game then offers even less of a glimpse of a black and white pattern. The screen remains blank for a number of seconds, and the same pattern then flashes again, only shifted a few degrees, either clockwise or counterclockwise.
To the right, very little,
okay,
or to the left.
The subject must indicate which direction the pattern turned. Reinhardt monitors the brain's activity during the delay between flashing images, while the stimulated attempts to hold information in his mind's eye.
We actually don't know yet if it can help someone with dementia like Alzheimer's disease.
But less than a mile away at Beth Israel's Barrington Allen Center for Non-Invasive Brain Stimulation, Harvard Assistant Professor of Neurology Dr. Emiliano Santarnecki believes he may have found a way to modify the disease using a similar method of electrostimulation.
Even though it might sound really surprising, they reported changes in their daily living. Some of them came back to driving their car by themselves.
Santarnecki's work examines inhibitory neurons, oscillating at a very specific frequency.
Which sounds like an alarm sound for the brain.
When that alarm sounds, our brains launch into defense mode, cleaning out harmful proteins. But as we age, we lose inhibitory neurons. Those with Alzheimer's appear to lose them even more quickly, allowing the buildup of the kinds of destructive proteins we believe hasten and advance the disease. Using a portable electrode cap for 1 hour a day for 2 weeks in one trial and 4 weeks in another, Santarnecki applied electrical stimulation at the same frequency of those inhibitory neurons to participants suffering from Alzheimer's to coerce their brains into attacking those bad proteins.
Ideally, one would also like to do it before the onset of Alzheimer's, which is the key.
The proteins scientists associate with the disease start to build up 10 to 15 years before Alzheimer's symptoms appear, seemingly and hopefully making our ability to slow, stop, and perhaps reverse the course of this disease possible, if we can detect those proteins early and if the work of researchers like Santarnecki and Reinhardt continues to advance in this field that studies the part of ourselves about which we likely understand the least.
It's a complicated machine. It's the most complex system that we have in the universe.
It seems like we're really at the frontier of the neurosciences. We're constantly confronted with our own ignorance every day in the lab.
In Boston, I'm Matt King, Fox 5 News.
Wow. Okay, and head to our YouTube page to see other big idea reports from our Fox 5 team.
It's all about avoiding those senior moments. They pop up on you, don't they?